Alright, hello class. So today's video tutorial is going to be about balancing chemical equations, and let's get started. Before we start the actual chemical equation balancing, we need to know a few things. Basically, that the left side of your reactant, the left side of your equation is going to be known as the reactants. The right side of your equation is going to be known as the product. So A and B here are terms just to represent substances. These are the ones that you're going to mix together. They're the ones that actually react, so we call them the reactants. Your byproducts, or what you end up making from that reaction, is going to be C and D, and those are going to be what we call products. And we're going to need to remember these words for future reference. Over here we've got a practice question that should be pretty simple, and I'd like for us to go over. If you're a bit more familiar with balancing chemical equations, you can pause it right here, go ahead and try it, and see if you can get the right answer on your own. If not, and you need a bit more guidance, please just follow along, and we'll go over how to do this properly together. So right now, again, if you want to do this on your own, pause it, go ahead and try it out. So here we go. What we do to start off in any type of balancing chemical equation question is make your chart. You make a box, you put a line down where you have your arrow, basically, and we start counting the different types of elements that we have. Here, in this question, since it's actually pretty simple, we only have a hydrogen and an oxygen, and we have that on both sides. And now that we know exactly what type of elements we have, all we have to do is start counting up how many we have on the reactant side and how many we have on the product side. So if we're looking at the reactant side, we've got 2 hydrogens and 2 oxygens. On the product side, we've got 2 hydrogens, but since there's nothing written after the oxygen, we've got 1. And the point of balancing chemical equations is that we want to have the same number on both sides, on the reactants and on the product. But you'll notice for oxygen, we don't have the same value. So what we're going to do is we're going to go where we have a lower value, and we're going to multiply it by something, in this case 2, to get the same value on both sides. So the number you're multiplying by is actually going to be the number you're going to be putting in front of the substance. So in this case, whatever contains the oxygen, which is water, gets a coefficient of whatever you multiplied your number by before. So since we multiplied 1 by 2 over here, we're going to put a 2 as a coefficient in front of the substance containing the oxygen. So now that we've done that, this doubles the number of oxygens we have, but it also doubles the number of hydrogens. So you always have to make sure you calculate what it affects. So it affects the oxygen, but also hydrogen. So now we've got 2 times 2, that makes 4 hydrogens. And our equality over here no longer applies. So we have to make sure that hydrogens are equal, and in order to do that, we multiply hydrogen by 2. And this is the last step. We now have 4 and 4 on both sides, 2 and 2 on both sides, but we have to take care of this doubling that we just did. So hydrogen just got doubled, so we need to put a 2 as a coefficient in front of the substance that has hydrogen. In this case, it is hydrogen. And it doubles the number of hydrogen to make 4 over here. So we've basically balanced our equation. Your final answer should be an equation, not the chart. So you can rewrite your answer as follows. And your answer is going to be 2 hydrogens, or 2H2, plus O2 provides 2H2O. So this is your final answer right here. There you go. Here we have a bit of a harder question that I want to go over with you guys, because most people, when they get harder questions, they kind of freak out. They get to a point where they no longer can continue, and they don't know exactly the procedure to follow in order to get that actual final answer. For those of you at this point who are somewhat getting more familiar with balancing equations, I would pause the video right here give this a try on your own before you listen through the actual explanation. So pause it now, I'll give you a few seconds, and come back for the answer. So everybody should be trying this one right now. So here we have a tougher question, but we're going to still go through the same procedure. We are going to make our chart. We've got our line at the arrow, and we're going to start counting the different elements we have. We've got a carbon, an oxygen, and a hydrogen on both sides. And here we go. We're pretty much setting up our chart. And now we have to start counting how many we have on either side. So for my reactants, I've got 1 carbon, I've got 2 oxygens here and 1 oxygen there, for a total of 3 oxygens, and I've got 2 hydrogens. On my product side, I've got 6 carbons, 12 hydrogens, which goes down here, and I've got 6 and 2 oxygens for a total of 8. So I have the option of either multiplying my carbon over here by 6 or my hydrogen over here by 6 as well. So I'm going to just go top down. I'm going to multiply my carbons by 6, and in doing that I get a 6. Now they're equal on both sides. I have to put this 6 as a coefficient in front of the substance that contains carbon. In this case, carbon dioxide gets a 6. And I have to make sure I always calculate what that coefficient over here affects. So it's multiplying my carbon by 6, but it's also multiplying my oxygen by 6. So I have 2 molecules, or 2 atoms of oxygen in this substance 6 times, for a total of 12 oxygens here, plus another one over here. Can't forget the one in the water, for a total of 13 oxygens. So now that I've calculated what it's affected, I can go back to my chart and see what I can do. Hydrogen, I can still multiply by 6. I'm going to do that to get my 12 so that they're equal on both sides, which means I have to put a 6 in front of the substance that has hydrogen, which is water. I put a 6 right there. Let's see what it affects. I've now got 12 hydrogens, so that's what I wanted, but I've also multiplied the 1 oxygen I have here by 6, so I now have 6 oxygens there, plus the 12 I still have over here, for a total of now 18 oxygens. And this is the point where most people get stuck. They've got an equal number of carbons on both sides, an equal number of hydrogens on both sides, but it's when they look at their oxygens that they notice that you actually don't have the same value. You've got an 18 here, and you've got an 8 here. There's no actual whole number I can multiply 8 by to get 18. So people kind of break down. At this point, in any type of question where like this, where you kind of get stuck, you kind of have to just go back to your chemical equation, this thing at the top over here, and look at it. We have a problem with oxygens. We also are lucky enough to notice that right over here in this box, we've got an oxygen all by itself, and it's on the product side, which is good, because our product's oxygen is lower than our reactant's oxygen. We have to ask ourselves, we've already got, if we take a look at our equation, we've already got 6 oxygens here. So we want to have a total of 18. We want to end up with 18. We already have 6. How many oxygens do we need, knowing we already have 6? How many oxygens do we need to get a total of 18? So it's basically what x plus 6 gives me 18. Well, that's going to be 12. That means that something times this oxygen over here should give me 12 oxygens to add to the 6 I already have over here to get 18. So if you do a little bit of math, you can realize that if you have a 6 over here, 6 times your 2 gives you 12 oxygens, plus, again, the 6 you have over here gives you that 18 you need to be equal on both sides. So this is pretty much the hard part. It's going back to your equation and looking at it to figure out that the answer for this balancing chemical equation question is 6CO2 plus 6H2O gives you C6H12O6 plus 602. And this is your final answer right over here. Alright, hopefully this has helped you understand how to do not only simple but more complex balancing chemical equation problems. Most of them will look like this one over here, where they're pretty simple. But if ever you do get to a question that is a bit more complex, don't forget, if you ever get stuck, go back to your chemical equation and look for that substance that's going to let you tweak it just by multiplying or putting a coefficient in front of it and rearranging your numbers. So this should be pretty much it for balancing chemical equations. If you do have any other problems or questions or concerns, you can always come see me anytime during recess or lunch. I'm always in my classroom. On that note, don't forget your assignment, and have a great night.